Hello, in this video I'm going to provide some guidelines and suggestions on conducting research in the social sciences. And these guidelines are also useful for some kinds of research in other fields, such as medicine. Now, we need new guidelines. The reason we need new guidelines is because there has been a change in the philosophy of what research is all about in recent decades. Up until, say towards the end of the 20th century, the great emphasis for a lot of people doing research in the social sciences was to obtain statistical significance. That's the kind of gold standard, the ultimate goal of the research is to get statistical significance, which means you get a p-value of less than 0.05 or even better, less than 0.01. So that was the goal, the target of the research. If you could cross that line to get to that low p-value, then you have a positive result. Well, in recent years, research methodologists and statisticians are saying, no, we shouldn't look at research as this race to get to the finishing line of statistical significance. So there's been a big move away from this emphasis. And what I'm going to propose is that rather than statistical significance being the paradigm around which research is conducted, we should take the concept from data mining and apply it broadly to research in general, and that concept is model building and model testing. So by having a clear visualization of what it is we are doing, it's going to help us stay focused and to remember these guidelines for conducting research properly. Because what I'm noticing is that as the emphasis moves away from this goal of getting statistical significance to whatever it is, it's left rather vague. There are mistakes being made that are just as big or even bigger than was made under the old paradigm. So suggestion number one is, I think it's helpful to use this terminology from data mining, that what we're doing in research is we're building models and we're testing them. And as we proceed in this tutorial video, I'm going to get very specific. This is not just abstract philosophy and semantics. I'm going to give some very specific guidelines of things we need to do given this new paradigm of what research is. And I'm going to point out that very often we're not doing these things. Okay, before we proceed, let's go over quickly what the old paradigm was. The old paradigm is you have a hypothesis, you collect data, and then you analyze the data to see what the probability is that that data would give you those results. And if you get lower than a 0.05 probability, or better yet, under a 0.01 probability, known as a p-value, it's statistically significant. That's the old paradigm. So as I said, it's a mission that you have in the research to try to get to that significance level to show that you have found a meaningful relationship between the variables. So it's like this race where if you cross the finishing line being 0.05 p-value, better yet, 0.01 p-value is like getting the gold prize rather than a silver prize, like a gold medal instead of a silver medal. For getting 0.01, you found it. That idea is dying away. And one historical note about this before I proceed, which is very interesting, is that Ronald Fisher, the genius who developed some of the fundamental statistical methods, advised that p-values were an informal guide to our research and not to be relied on as a kind of black and white criterion for making discoveries. So Fisher saw the p-values as important, but not as this great, this sole and only way of distinguishing a positive result from a negative result. It's just one helpful tool along the way. And here's a website that discusses that. Okay, now what is the new paradigm? Here are some suggestions that have been made about changes that are needed and I think everybody agrees with this. So I'm going to go over some of these, you might say, more obvious adjustments to how we conduct research and how we report results. And then I'm going to show some less obvious suggestions and guidelines for how we need to conduct research and report results. But first, the ones that have already been talked about. Number one, emphasize effect sizes. So anybody who's a statistician or a research methodologist knows that if you have a large sample size, you can get statistical significance, but the actual effect from the predictor variables can be very small, and so small as to have no practical significance. So statistical significance depends a lot on how many people, assuming you're studying people, are being studied, are in your sample size. More important in many ways than the p-value is what is the effect size, because the effect size does not vary depending on things like your sample size, whereas the p-value depends on the context. So it gives you a more independent, less context-sensitive measurement, and also a more useful measurement. So there's an emphasis now on reporting effect sizes. That makes sense. It's pretty obvious. I think just about everybody endorses that. Another change being made is, rather than look at your study as an isolated fact, isolated from everything else that's ever happened, and just saying, okay, I got 0.01 probability in this study, I got a 0.01 p-value, it's a great study. Think about it in context. If you have a hypothesis that has very little previous research done to support the hypothesis, it's less likely that you really found a meaningful relationship than if there was a lot of supporting research. This is sometimes called the Bayesian perspective as opposed to a frequentist perspective. So some modest amount and common sense amount of Bayesian considerations is important, and I think this is generally being recognized. Here's a website link that gives some good examples that make it very clear that we don't want to make believe that our research is done in isolation from everything else once we analyze the results. Third point, which is something that's always been known, and it's really just enforcing rules for research that have always been there, is to stop p-hacking. P-hacking goes under several terms, but what p-hacking is essentially is doing things like continuing to collect data until you get statistical significance. So you keep adding more data to your sample size until you get the result you want, or you keep trying different hypotheses or variations of the hypothesis until you get statistical significance. That's fine to do if you're doing exploratory research. If you're just trying to build a model. But what people are doing is they're cheating, and they're reporting that as their p-value. And in statistics and research methodology, we have procedures to take care of these things. For example, there's something called a Bonferroni correction that you use, and there are other adjustments that are appropriate when you have multiple hypotheses. So what's happening is that researchers are sometimes cheating, and they are p-hacking. This is not surprising when somebody's career and success and stature is all dependent on having impressive research. There's going to be this temptation to do p-hacking, and sometimes it's unconscious, not even consciously done. So everybody agrees about that. And a fourth thing that's being done now is an emphasis on publishing studies with negative findings. Now, this is an idea. I don't think it's always going to get implemented, because many academic journals are going to publish a limited number of papers. Those papers that get positive findings are often more exciting. So what this emphasis of publishing positive findings does is it gives us a biased reporting mechanism where we're seeing only the positive findings much more than the negative findings. So there's an awareness of that and attempts to correct that as well. These are some of the common sense things that researchers are becoming aware of, and the awareness of this has now spread everywhere. It's no longer just a small movement like it was, say, 20 years ago. Now it's becoming established. Back in 1999, the American Psychological Association issued a statement on proper research procedures, and it provided guidelines for properly conducting research and for reporting results. And they point out the abuses of p-value and putting so much emphasis on p-value, disregarding things like effect sizes and confidence intervals and ignoring issues. There are many, many issues, what the power of your statistical test is and so on, that by isolating down to p-values, how that's not a healthy and constructive way to do research and to discover knowledge. And more recently, the American Statistical Association published a paper on how to properly use p-values, and 6 key points made in that paper are summarized in a paper published in March 2016. Here's the website for that. So this is just to let you know that this bridge has been crossed, this bridge away from the old paradigm to the new paradigm. And what I'm doing in this video is making clear what this new paradigm is, making some suggestions for how we can visualize what this new paradigm is and how we can properly conduct research and report results. And I'm already seeing lots of poor practices. So let's, leaving bad old ideas is not going to be helpful unless you replace it with new good ideas. And we really need to replace them. And that's some of the points I'm going to emphasize here, is the things we need to do that we're not doing in the new paradigm. Okay, so those changes that I just mentioned are good. They're not enough. And I started making this point before. Let me repeat it. First, I'm suggesting that we endorse this terminology from data mining, that we think of our research as model building and model testing. Or we have redundancy of the word model, you can just call it model building and testing, or MBAT for short. So we can say that rather than statistical significance as the overriding primary important thing in research, our perspective now is MBAT, model building and testing. Now, an interesting thing about MBAT, it's not just an idea from data mining, it's actually been an idea in the hard sciences. Going back decades, the Nobel Prize winning physicist Richard Feynman stated that model building and model testing is the essence of scientific inquiry. He doesn't use that terminology, but I want you to listen to just 1 minute of a video of Richard Feynman teaching a class and how he describes what scientific research is. He does not say that it's the scientific method and going through all those procedures. He says you take a guess and you test. That's all there is to it. We can call that guessing the model building, because after you guess, you tinker with your guess and then you start to test it. So here's Richard Feynman describing what the hard sciences are, what physics is, how you make progress in physics, and I think this same concept is what is needed in the social sciences. Here we go.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
Okay, so there you have it. It's that simple. So by thinking of research in the social sciences in the same way, I think we have a much healthier and productive way to conduct research. Now, I'm going to give you 10 guidelines for how to conduct research and report results in this new era of looking at research as model building and testing rather than as a challenge to get to statistical significance. Number one, since research is about model building and model testing, the very first thing is be clear about what stage your research is in. Are you at the very beginning stage of making that initial guess, or are you at the very end stage of doing another confirmation of a theory that was already supported by previous research, just to make it rock solid, or somewhere in between? And the temptation is to exaggerate the stage of the research. And this is what I'm seeing very frequently in many areas now, is we've gone from p-hacking to exaggerating what stage we're at from model building to model testing. So that's the critical issue. And to be more specific about it, point number two is more specific details about what I just said in point number one, which is, for example, are you using training data or testing data? So if you're looking at data, information, and you're refining your ideas, and that's primarily what you're doing, then you're building the data. If you're getting new data and you've already got a model, and notice we use this word model more often than theory. You can use the word theory, but you have a model and you apply it to the new data. So what's happening is people are reporting results from their training data as if it's testing data. And they're saying, I found that this group of people have this in common, or these things are involved with their behavior. If you're just building a model, that's a big jump. You're exaggerating the results. You can only say that when you're in the testing phase, that you have suggestions of a good finding. And notice that a lot of research is transitional between these, because after you build a model with some test data, then you get some more data to test the model you've built. Maybe on this next group of data, you get slightly good results, not really impressive. So you improve the model based on those, and you apply it again. So each time you apply the model to new data, the model has improved. So you're actually doing two things. You're testing and improving the model. But you want to distinguish as you test what you stated the model was before you gathered the data and what the results are based on that, and then how you changed it. So this is not radically different from the original concept of research, where you have a hypothesis and you test it. You're still doing that. But by framing it in this context of model building and model testing, it removes us from this emphasis that we're struggling to get to a certain p-value. And it opens the door to a lot more things that are important, as I will describe now. Now, when you build your model, you build your theory, you have a set of predictor variables. If that set of predictor variables is not consistent, it looks like a hodgepodge of different things, it is unlikely that those predictor variables will be validated with test data. It's not impossible, but it's extremely unlikely. So, for example, data mining experts like Sam Roweis really emphasizes, I've seen it in my own research over and over again. I was doing one research on predicting gold prices. I had two models. You don't have to have just one. One model that fit my training data very well, but it was less consistent. Another model that had lower correlations, but it was a simpler formula. When I tested on new data, which formula worked better? The one that had more consistent and simpler predictor variables. So these are things to think about. What I'm seeing getting reported in some research now is people are doing model building a model with a lot of predictor variables that look arbitrary, and claiming that they found a relationship. Well, first of all, you shouldn't claim you found a relationship if you're still in the model building phase. Worse yet, they're doing it with a model that has inconsistent predictors, no clear theme going on, and this ties into point number 4, and perhaps no theoretical basis for it. So on the other hand, if you have predictor variables that are simple and consistent, and you have a theoretical explanation for them, there's a much higher probability that you will get positive results when you apply your model to new data. So we see that not everything can be reduced down to numbers. There are considerations about the model you've built and what the likelihood is that it will work with new data. There are surprises in research. That's why I call it here a shot in the dark. A set of predictors with no basis in theory is a shot in the dark. Every once in a while, a shot in the dark works. It hits the intended target. Usually it doesn't. So these are the best practices, things to be aware of. And even though these points are so simple and so clear, it's amazing how often people are not following these guidelines. And we're just as bad off as we were with the old paradigm of trying to get statistical significance if we don't follow these best practices in our research. Okay, point number 5 I want to make is right now a lot of researchers see a big divide between the qualitative research and quantitative research. There are people who do qualitative research who are critical of quantitative research, for example. And what we're seeing now with this paradigm that research is really about model building and model testing is that a lot of qualitative research is that initial stage of model building, what Richard Feynman called the guess, by seeing what the behavior is, by analyzing it, by observing, by making notes and observations and recordings, or many kinds of qualitative research help identify what's going on, bring in content expertise, very important, people who understand and work on this over and over again and develop an understanding of what's going on. That understanding sometimes is an intuitive sensitivity to what's going on, as well as it may be clear understanding of particular relationships that go on. So even though some qualitative researchers may not like the idea that their research is important for quantitative research and can be seen as a first step in this whole spectrum of activity from the initial model building to the final model testing, much of qualitative research fits in that category. Not all of it, but I just want to point out that we don't need to ignore qualitative research and think of it as something distinct from quantitative research. And my last sentence here, by the way, I see lots of typos. You may see them as well. Don't worry about it. But my last sentence here is, I use qualitative analysis of extreme cases, and doing this I've made dramatic step forwards in my early exploratory studies. I've come up with concepts, models, ideas that I would have never come up with if I hadn't done the qualitative study of extreme cases, and I have separate videos on what that's about. So this new view of research as a spectrum from model building to model testing opens our minds to the richness of methods and how they can work together, and the old way made some false distinctions, and it sometimes made us feel like qualitative is not relevant when very often it's extremely relevant. Bottom line is sometimes qualitative research can be very important, and I have videos on how I've gotten more progress doing some qualitative studies than I did with the data mining research that I was doing. Okay, point number 6. This relates back to the first 4 common sense adjustments that people are making to research, which is the Bayesian perspective, to be aware of what other evidence you have beyond your own research. I phrase it differently here. And extraordinary proposed relationships require extraordinary support. So if, for example, there's been a large amount of research that shows obesity is increasing in a particular geographic region, and then there's a new study that shows that obesity is not increasing, then there is a strong likelihood that this finding that obesity is not increasing at, say, a 0.01 p-value, maybe it's that 1 in 100. This p-values are just probabilities. Or maybe we need to think about the variables in some kind of new way. But it's unlikely that there's no increase in obesity just because this one study shows that there isn't. So we have to interpret our results in the context of previous knowledge. And my bottom paragraph here is that completely new and unsubstantiated ideas also should be accepted with much greater caution than ideas that have support from earlier research. It's common sense. So building in this Bayesian perspective of what other information do we have in addition to this study is very important. Point number 7, and this maybe should be point number 1. This is extremely important. We cannot exaggerate the importance of this. Is strive to remove selection bias from your data. This might be the most important guideline for best practices. I repeatedly see violations of this guideline when there are alternatives, when there are ways to remove selection bias. So where did the data you're studying come from? Usually we're not studying the entire population. We've selected cases out of it. And if there's any possibility that the way that data was selected is related to what you're looking for, you have a very weak study. So sometimes people use client data, for example. They're practitioners. Maybe they're psychologists or therapists, whatever the case may be. That's good for exploratory research, but you're very limited in your ability to feel that you've come up with any kind of solid findings. It's good for the initial exploratory stage. Then you need to do research on data where you have no control over that. Extremely important. And also, keep in mind that research is a practical endeavor. It is extremely rare to be completely sure of anything. So sometimes people get very philosophical about this and they say, well, I can't be 100% sure that there's no relationship. Well, that's not what research is about. Research is not generally about some abstract philosophical thing. It's about the reality of it. If you have a database that you didn't gather, that was supplied in some independent way, well, very clear, and it has no connection to the model you're building, you're on safe grounds. We don't have to get very abstract about it. Realistically, you've got a database with virtually no selection bias. That's what you're looking for. So be practical about it. Being practical about it means if it's data that you've somehow been involved in collecting through some mechanism that's not defined external to yourself, such as a computer program or some other mechanism for getting that data, if your hands are involved in it, so to speak, there's a very high probability that in some subtle way, if not overt way, the data is biased. Extremely, extremely important, and also gets overlooked. All these guidelines are to tell you how solid your conclusions are, how strong are your suggestions from the findings. If you have data that could be biased, you're still at a much more early exploratory stage, if that's the case. Okay, another point is, and taking this idea from data mining also, is be familiar with what you're studying. If somebody comes into research and they're doing, say, medical research on causes of cancer or diabetes or whatever it might be, and they're not medically trained, they have no training in biochemistry, they haven't worked in this area, they're not familiar with the statistics, they're not going to be good at researching this. And if you take a person who has knowledge of the field and then they look at the data, what is the age distribution of people with diabetes? What is the male versus female? What is the difference in different geographic regions where people may have different diets or different lifestyles? You make friends with the data. Very, very important. So we are no longer in a game where we win a prize for obtaining a 0.05 or 0.01 p-value. We are on a quest to gain greater understanding through model building and model testing. getting an intuitive feel for the data, seeing how the data is distributed, seeing what variables have interesting or unexpected distributions, often leads to insights and discoveries. So research is no longer this mechanical process where you just crunch numbers. You're using all of your resources, including your expertise in the field, your discussions you have with colleagues, your intuition, your rigorous analysis of data. All this works together. So not everything in quantitative research is a dry, mundane number. All of this is part of it. So these are best practices for research in the 21st century. Is you get an intuitive feeling and you visualize. Data visualization is very important. Graphs are extremely important. We've always known that, but these are things that are given special emphasis and need to be emphasized as best practices for research. 9, as we talked about, pay close attention to effect sizes, confidence intervals, things like measurement error, rates of false positives and false negatives, the power of the statistical test. Not all of these apply to every kind of research, but whatever kinds of limitations and requirements, ways of understanding what you're analyzing, what statistical tests or methods you're using need to be incorporated. We're no longer in a world where we have a simple linear goal, which in the old days was get statistical significance. Now we're looking at all the complexity of the issues that are relevant to our findings. And this is true regardless of what kind of research are being conducted, is to be aware of these other things that are affecting what you're seeing. It's common sense, but in the old paradigm it was not done enough. Everything was just this simple linear goal of getting 0.05. Now we're looking at the complexity of the situation. So in this new model, this new paradigm of model building and model testing, there are some issues that we can't put a number on. You can't quantify every part of this process. And so we need to be aware of that and to utilize all these things to have the best chance of making discoveries. Point number 9, what about p-values? P-values are still good. P-values have become very intensely debated in recent years. Virtually everyone knows that they've been abused, but swinging to the opposite extreme of declaring them verboten is not what we're advising. Let me give you a practical example. Suppose you're looking at a Pearson-R correlation of 0.30 and you have a sample of 20 cases. It's helpful to know what the probability of obtaining that result is. Suppose you get a 0.30 correlation with a sample size of 50. Your p-value is going to be higher because you have a larger sample size, but knowing exactly what it is a good guideline. The term statistically significant can be thrown out. We don't need it. But p-values are still important guidelines to show how well we're doing with our model. The goal is not a low p-value. That's not the target of everything we're doing. But p-values help guide your research by letting you know how close you are to finding a certain relationship between variables in certain situations. And this is a case where it's a helpful guideline. It's nice to know. It helps steer you in the right direction. If you have a low p-value, it does suggest you're on the right track, everything else being equal. It is one thing that can help. Another point is that in the old paradigm, where the race was to get to a 0.05 or 0.01 or whatever level of statistical significance, the early stages of research where somebody might be bumbling around, trying one guess, trying another guess, they weren't very exciting because you're unlikely to produce a paper that shows a valid finding. It was the end of the race was given all the attention where you're in the confirming it, because that's where you can show that there is a result, and that's exciting, and you have a higher probability of getting published. Well, with this new paradigm, we give, you might say, respect or appreciation for all stages in this process. research into areas that have little research literature, and therefore the literature review section of the paper might be almost non-existent, would be heretical in the old paradigm. You wouldn't write a paper with no literature review. In the new paradigm, this is welcome in an appropriate venue, depending on what a research journal or a research team is interested in. I'm not saying everybody should be open to completely new paradigms. It could be a waste of money, but there can be research institutes or departments in universities or research teams that have certain hunches that are pioneering in new directions. So knowledge discovery can be contributed by radical pioneers as well as people at the opposite end of conducting final hypothesis tests. It's a bigger gamble. Maybe a fund for research doesn't want to invest in these wild gambles, but it's not something that can be just dismissed. Sometimes these innovators, radical departures, new guesses, every once in a while they open up something new. So these are new perspectives that we have when we look at research as this continuum from model building to model testing. And think about words here in this last paragraph. Words like science and pseudoscience, they get reinterpreted in this context. Let's take something way out in left field, like astrology. Suppose an astrologer claims a relationship between variables. And the astrologer makes this claim without making any sincere attempt to confirm the relationship. We can call this pseudoscience. The astrologer is claiming that he or she is at some level of hypothesis testing and has gone through that when in fact they haven't. On the other hand, people in fringe fields who are guarded in their conclusions, they recognize that they're in the initial stages of exploratory research, and in this case, it's not really pseudoscience, you might call it fringe science. It's some kind of new field of inquiry. As long as the researcher properly establishes what stage they're in their research from early initial model building to the late model testing, all those are useful. Because if you didn't have the beginning, you wouldn't have the end. So they're all useful. So we get a new respect, a new appreciation for the broad spectrum of what we're doing with research. Just as I mentioned before, we get a new appreciation for the contributions of qualitative research for building new initial, what Feynman called guesses in our research. If you don't have the right guess, you're not going to get the right result in the end. So all of these things are very, very important. So conclusions. What I'm proposing here is a clear image and a visualization of the new paradigm for scientific inquiry in the social sciences that replaces the old model. And we can call this new model, this new paradigm, model building and model testing, or a little shorter is model building and testing, and even shorter is MBAT. So MBAT is replacing statistical significance as the concept, the underlying premise of our research. And this is not a new idea. I'm just suggesting that this idea be embraced and supported. And interestingly, this also brings the social sciences into alignment with the hard sciences, as described by Richard Feynman anyway, in terms of research methods and research philosophy. These are very simple guidelines that I've proposed. For the most part, they're very common sense guidelines. Much of it may seem so obvious. You may say, why are we spending so much time on this? The reason we're spending so much time on it is that these guidelines are typically, I shouldn't say typically, but very often ignored. Also, having colleagues to help us stay on track is very helpful, because we are human. Nobody is likely to be consistently on track all the time. Sometimes there are fine nuances and issues that arise. So research is best when different people all help contribute, because we're researching, we're discovering something new, and there's always subjective elements involved, even in quantitative research. And having different people's point of view helps. And by the way, I obviously haven't mentioned every important guideline for research in this new era of model building and testing, but I've just presented the ones that came to mind. I'm sure some of you will think of additional ones that are important. So Acknowledgements. I want to thank my colleague Renee Ashep for the references to the journal articles that she supplied me with. I want to thank her and also many other colleagues for their insights, and I want to thank my professors that I had when I attended the classes at the University of Florida. So that's it, my friend. Those are my suggestions for best practices in research in the social sciences and often in other fields as well. Here are some resources. Those of you watching this video as students of research methodology and statistics might be more than surprised, might be shocked that I worked in the field of astrology. Believe it or not, it's true. And these are some of the resources that I'm involved in. Here's the YouTube video page, the astrology software page, the School of Astrology that I teach at, online astrology reports, and other free services. And we have some books and the features we've implemented in our Kepler and Sirius software to advance research in astrology. Okay, I seem to be losing my voice, so maybe it's good I'm at the end here. This is a long video, 41 minutes. I hope that was helpful, my friends. God bless. Namaste.